The next example for general power formula has a root. Learn how it is differentiated here in differential calculus. What is the general power formula? Comparing the two power formulas, the first is simply called power formula. The derivative of x raised to n is the exponent n multiplied by the variable x, this time raised by the original exponent less 1, with the derivative of that variable x all over dx. With this formula, the derivative is its at simplest form. In this case, it's x, which, when used with chain rule, provides dx upon dx, which instantly cancel out. The general power formula, on the other hand, has the same format, although instead of just a single variable x, a function is involved, although it is simplified in the formula as u. The procedure is the same, which has the exponent made into a coefficient times the function raised to n minus 1, with the derivative of u with respect to x. With such format, we can no longer cancel out du with dx, as du is still a function. The second example for general power formula includes the function y as equal to x squared times the root of the binomial 1 minus x squared. In order to solve the function, convert the radical sign into a fractional exponent. The root of 1 minus x squared can also be written as the same binomial, 1 minus x squared raised to 1/2. Now we are ready to differentiate the function. Note that it has two terms. The first is x squared, and the latter is the quantity of 1 minus x squared raised to 1/2. The two terms can also be notated as u and v, and note that they are multiplied. Thus, we should employ product rule. From the rule, dy over dx is the first term, multiplied by the derivative of the second. Then add the copied second term, multiplied by the derivative of the first. Although long, we use product rule as we cannot simplify the function algebraically because of the root. From the outcome of the product rule, we can use power rule for the second derivative. But the first derivative requires the general power rule, as it has u of 1 minus x squared instead of just a simple x. So let's attempt to differentiate. Dy over dx is then the copied terms x squared and the root of the binomial 1 minus x squared. Let's work on the second derivative, as we are more familiar with the operation by now. The derivative of x squared is 2x times dx over dx, where dx upon dx is equal to 1. For the group involving general power formula, take the exponent as a coefficient, that is, 1/2. Then copy the binomial 1 minus x squared with the original exponent minus 1. Include in the quantity the derivative of u, which is the binomial 1 minus x squared. The second term is already free from any d's, but there's still d over dx of the binomial from the first term. So distribute d over dx among the terms in the binomial, making dy over dx as a copied x squared with half of the binomial of 1 minus x squared raised to negative 1/2, and then multiply the individual derivative of 1 minus the derivative of x squared. The derivative of a constant is taken as 0, so dy over dx is then a copied x squared with half of the negative root of 1 minus x squared. Multiply with this the derivative of x squared, which is 2x, times dx upon dx. Also add the second term of 2x times the root of 1 minus x squared. We are already aware that dx upon dx is 1, simplifying the derivative. This time, we already eradicated all these in the derivative. So let's just arrange terms. Take negative 2x out front and place the negative exponent as the denominator. Thus, negative 2x cubed all over 2 times the root of 1 minus x squared. Then add here the second term, which remains unchanged. Through algebra, let's simplify the terms. Take the least common denominator to make a single term. The LCD is the quantity of 1 minus x squared raised to 1/2. The numerator has the same negative x cubed, and the next term carries 2x multiplied by 1 minus x squared raised to 1/2. This time, this is multiplied by the LCD, which is the root of 1 minus x squared. Combine quantities to reduce the derivative. To make negative x cubed with 2x times the binomial 1 minus x squared. Distribute 2x and get the numerator of the derivative as negative x cubed plus 2x minus 2x cubed. Collect similar terms to come up with negative 3x cubed plus 2x upon the root of 1 minus x squared. As the radical sign isn't allowed in the denominator, rationalize the derivative, and that is done by multiplying the root of 1 minus x squared all over the same quantity. This rationalization makes dy over dx as the same quantity of negative 3x cubed plus 2x multiplied by the root of 1 minus x squared all upon the binomial 1 minus x squared. From here, the denominator is clear from any radical sign, so we can take this as the final derivative.